Have you ever looked around and wondered why everything in the physical world behaves the exact way it does? Why things move, stop, or suddenly turn? We're diving into an explainer today called Force Made Clear. We often take these everyday events for granted, but there's a hidden, invisible set of rules governing literally every interaction around you. By the time we wrap up, you won't just see objects anymore. You'll see the invisible forces actively shaping our reality. So let's jump right in with a simple yet profound question. Why do objects change their motion? Really think about it. Why does a parked car sit perfectly still until an engine or a person acts on it? Or if you kick a ball across a field, why doesn't it just keep rolling forever? You might think of force as just a push or pull. That's close, but it's not the whole picture. The crucial point is beautifully summed up by a simple rule. Force is a cause, and motion is the effect. Force isn't just some label we stick on movement. It's the hidden cause behind any change you observe. Whenever something starts, stops, speeds up, slows down, or changes direction, a force is the author of that story. Once that clicks, the physical world starts making a lot more sense. Let's sharpen this idea. Force is absolutely not some magical substance stored inside an object. You can't just pour force into a cup. Instead, it's fundamentally an interaction between objects. Think about opening a heavy door. You aren't transferring a physical substance into the wood, you're interacting with it. Your hand pushes the handle, and the door responds. The force is that specific interaction changing the door's motion. Which brings us to a brilliant way to think about this. Force is a relationship, kind of like a handshake. A handshake simply can't happen with only one person. In the exact same way, a force doesn't appear all by itself. It happens when one thing acts on another. Sometimes this is a contact force, like pushing a box. Other times, it's a non-contact force acting across a distance, like magnets snapping together, or Earth's gravity pulling a stone. It always takes two to interact. We usually learn that force changes motion, but it's much broader than a simple shove. Force basically has two main effects. Yes, it changes motion, making things start, stop, or speed up. But it also changes shape. It can stretch, compress, bend, or twist an object. Force is any interaction that alters a physical state, expanding our understanding way beyond just watching an object travel from point A to point B. Let's make that more concrete. When you press down on a lump of dough, it squishes and flattens out, right? When you pull a metal spring, it stretches. If you press hard enough on a metal spoon, it bends. In all these cases, the force is physically rearranging the object itself. These shape changes are direct, undeniable evidence of force actively at work, even if the object isn't traveling across the room. What's really fascinating about these interactions is the concept of direction. Force isn't just about how much effort you apply, it heavily depends on which way you apply it. Imagine pushing a shopping cart. Push it straight, it rolls straight. But apply that exact same effort at an angle and it veers off to the side. Direction isn't just decoration, it's a critical part of the force itself, dictating exactly how motion changes. Force can sometimes feel tricky because the forces themselves are often completely invisible. You usually can't see a force with your own eyes, but you can always see what it does. Think of a curtain fluttering. You can't literally see the wind, but the moving fabric tells you without a doubt that an interaction is happening. When a rubber band snaps back, you're seeing the visible effect of an invisible cause. This builds into one of the most fascinating rules in physics. Interactions go both ways. Force is never a one-way command. If you push as hard as you can against a solid brick wall, you physically feel the wall resisting your hands. As you push the wall is actually pushing right back on you. If two people lean against each other, both exert force. Every single interaction is a mutual, two-way street. Now, it's super tempting to think a huge push always results in huge movement. We measure the strength of a push or pull in standard units called newtons. A small force of just a few newtons easily sends a lightweight chair sliding across the floor. But that exact same force barely budges a massive wooden cupboard. A bigger force doesn't automatically guarantee a bigger effect because an object's mass and natural resistance play a massive role. In the real world, force rarely acts entirely on its own. Real motion comes from multiple forces competing and combining, all at the exact same time. Take a simple book resting quietly on a table. It looks like absolutely nothing is happening, but in reality, Earth's gravity is constantly pulling it downward, while the solid table pushes it straight upward. that book is caught in a delicate, invisible balance of multiple forces. And that perfectly sets up the difference between balanced and unbalanced forces. When forces perfectly cancel each other out, like that book, we call them balanced forces. The object stays exactly where it is, or continues moving steadily. But when one side wins that tug-of-war, the forces become unbalanced. It's only when forces are unbalanced that an object is forced to change its speed or direction. This next concept is often counterintuitive. A moving object doesn't necessarily need a continuous, constant push to keep moving. If you roll a smooth ball across a highly polished floor, it keeps going for quite a while without you needing to keep pushing it. The only reason it eventually stops is because hidden, resistive forces are quietly stealing its motion away. Without those hidden forces, it would just keep gliding forever. The most common of those hidden, resistive forces is friction. Friction appears whenever two surfaces touch and resist sliding past one another. It's why your hands get warm when you rub them together quickly. It's why your shoes can grip the pavement without slipping. Friction acts as a silent brake on almost everything moving around us, constantly opposing motion and slowing objects down. With these rules, you can stop guessing and start reading the world like a physicist, using observed motion as a diagnostic tool. If you see an object at rest or moving perfectly steadily, you know the forces acting on it are balanced. But the moment you see an object speeding up, slamming on the brakes, or veering around a corner, you instantly know the forces have become unbalanced. The motion literally tells you what the invisible forces are up to. Let's look closer at turning. Force doesn't only affect speed. Imagine motion as a straight arrow. An unbalanced force can stretch that arrow to make you go faster or shrink it to slow you down. But it can also grab that arrow and rotate it entirely. When you turn the handlebars of a bicycle, the force you apply redirects the motion. The bike wants to go straight, but your force actively steers it into a curve. Let's put this together in a messy, real-world scenario. Think about navigating a heavy cart through chaotic city streets. You aren't just dealing with one simple push. You're simultaneously managing your forward push, the silent brake of friction in the wheels, the resistance of uneven roads, and the sudden unbalanced forces of braking and turning to avoid obstacles. You're constantly balancing a beautifully complex system of competing forces. This is the identity shift we talked about at the beginning. Once you understand this deep structure, that every single movement, stop, and bend is the result of competing interactions, you're no longer just looking at a ball or a bicycle. You're looking at a readable language of cause and effect. Ordinary things become a fascinating display of forces and responses, giving you a powerful mental model to understand the world. Armed with this new mental model, take a look around the room you're in right now. Look at the objects resting quietly or moving outside your window. Ask yourself, what silent, invisible interactions are holding your reality together at this very moment? What forces are perfectly balanced? And what would it actually take to unbalance them? Keep that curiosity alive because the invisible world of force is always there, just waiting to be understood.